So in the previous video, we introduced two different sets of coordinates, 2, 1 and 6, 4, and we calculated the distance between them, we calculated the midpoint, and we also calculated the gradient. Now the gradient is what we need for this part of the video, and the gradient was equal to 3/4. Now, when we have 2 points, as I said before, we can connect a straight line that goes through them. So we have the interpolation here, the extrapolation on the outside, but what's most important is that we just find the line that goes through the 2 points. So I've just extended that all the way throughout our normal Cartesian plane, okay? Now, the general form for a linear equation in VCE methods is y is equal to mx plus c. So y and x are just, our normal variables in our equation. So we have y here, x there. The m is our gradient, which I said is 3/4, but yeah, just in general, it's just a gradient. Now c is just the y-intercept of our equation. Now, if you forgot what the y-intercept actually is, it's where our equation or our function just in general passes through the y-axis, okay? Now, when we're constructing our linear equation, this is almost just like a byproduct of the equation. So it's just an easy way to read off, okay, that's the y-intercept. It's not necessarily something that we purposely find and then put into our equation. It's just that value on the outside, and then it just ends up being our y-intercept. And I guess if you want to find out why it's the y-intercept, but for the reason why that ends up being the y-intercept is because y-intercepts happen when x is equal to 0. So if we think about a y-intercept, it's on the y-axis, and that happens when x is equal to 0. So if we let x equal 0 in our general equation, what happens is we get y is equal to m multiplied by 0 plus c. M times 0 is obviously 0, so we're just left with c. So you can see our y-intercept just ends up being that value on the outside, okay? Nice. Now, we found our gradient before. We said how we calculate it is y2 minus y1 over x2 minus x1. So for our equation, we know that y is equal to 3/4 x plus c. Now we need to find the c value, or that value on the outside of our equation. How we do that in a general sense is we plug in any one of these points. So I'm just going to choose a point randomly. We'll say 2, 1. I'll do this in a different color because this is kind of a key step. So we say 2, 1 is a coordinate that lies on our line, and therefore we're going to substitute that in. So x is equal to 2, y is equal to 1. So y is equal to 1. 1 is equal to 3/4 multiplied by x. In this case, it's 2 for this coordinate, plus c. Nice. Now, what we do is we just multiply this 2 and this 3/4 together and move it to the other side. So we get 1 minus 3/4 times by 2. That ends up becoming 6/4, which is 3/2 is equal to c. Therefore, c is equal to 1 minus 3/2, which is 2/2 minus 3/2, ends up being -1/2, or -1/2. Therefore, y is equal to 3/4 x minus 1/2 as our linear equation. Nice. Now, one question that I always get is when I have this type of problem and I have multiple different possibilities for points that I plug in, which one should I actually plug in? Now, it actually doesn't matter. I plugged in 2, 1 randomly, but I could have also plugged in 6, 4, and I would have got the same answer. So I could just prove that too. If I plug in 6, 4, what happens is I get 4 is equal to 3/4 multiplied by 6 plus c. 4 is equal to 3/4 times by 6 ends up being 18/4 plus c. Therefore, c is equal to 4 minus 18 divided by 4, which is 16 minus 18 divided by 4, which is -2/4, which is -1/2. That was getting low. My wrist was hurting. But yeah, ended up getting -1/2 as my c value, which was the same as I got previously. So you can see that I can plug in either point that lies on my curve, and I get the same c value, and therefore the same equation. And that's kind of the point of our linear equation, is that if you have any point on this line, and you know it for sure, it lies in that line, then I'm going to get the correct c value, as long as I have the correct gradient as well. So it actually doesn't matter which point I substitute in, as long as it's a point that lies on the line, then we're good to go, and that'll give us the right equation. So you can see y is equal to 3/4 x minus 1/2. It's in that form, y is equal to mx plus c. Now, another form that your linear equation might be in is something that looks along the lines of this. Again, I would just leave this as a final answer personally, because it's not telling us, this question presumably is not telling us what form to put it in. It's just saying to find the linear equation. This is perfectly fine, right? Least amount of steps, less room for error, okay? But a lot of the times you might see equations, and questions potentially could tell you to put an equation into this form here. What I want to do is I want to get rid of the fraction first off. So I'm going to multiply 4 to the other side. So what I get is 4y is equal to 3x minus 2, because multiply that by 4, you end up getting 4 over 2, which is equal to 2. Therefore, 4y minus 3x is equal to negative 2. Therefore, if I just take a negative out of both sides, 3x minus 4y is equal to 2. Now, this equation is another form that you might see a linear equation in. You've got the x and the y terms on one side, and then you've got a constant on the other side. And usually in this form, the fractions are kind of removed from the equation. And there's nothing too particular about this form. Same way there's nothing too particular about this form, apart from the fact that you can read off specific values. I'm not too well versed with this form of the equation. I'm not sure exactly how to read off values from this one, but I think I've read somewhere in the past that you can read off x and y intercepts based on some combination or something that you can do here. Again, I don't really know because it doesn't really matter. But it's just a different way of expressing the same thing. This is a linear equation. This is exactly the same linear equation. It's the same if you go back to quadratics from last year or year 10. If you have the equation in expanded form, that's one way that gives you a certain amount of information. If you have the equation in turning point form, as the name suggests, you get the turning point. So you get different pieces of information based on the form that you're in. So it's exactly the same with this case. You have one form, you have another form. If the question doesn't tell you which form to put your linear equation in, you could put it in either one. But if the question asks you to put in the form y is equal to mx plus c, we're expected to put in this form. If the equation asking us to put in ax minus by is equal to c, if it's asking us to put in that form, then we'll put the equation in this form, as the steps suggested here.